Let's talk about storage now. In previous sessions, we already mentioned that in a typical data center, there are three types of servers or nodes, administrative nodes, right? We use that to access all the internal management of a data center. Then there's a compute node and the storage node. So compute and storage are the two sides of cloud computing that is actually serving your need. Compute is easy to understand. You do all the calculations and those are manipulations, logical operations. How about storage? Storage is usually like less considered until you discover there's an issue. But but indeed, storage is as important as compute. That's an integrated part of computing. So why are you concerned about storage? There are, of course, many different ways, but just for the purpose of this course, that we are all science students, right? Data engineers. So let's focus on data because in general, whenever you generate data, you have to store it somewhere. The processing system, like transactional system, they only have a limited memory and CPU, and they have to focus on the incoming information, incoming requests. They cannot hold the data forever, so somehow they need to store it somewhere. And this data are usually stored as files in an external hard disk. Then also, um, these days, inside any enterprise, it's inevitable that you will have a data exchange between different applications. Typically, when you have a transactional system generating your daily sales information, eventually you need to send this to finance department, calculating the revenue, the profit, or lose of that day. And that data transfer usually happens through a file. The transactional system will generating a data file, and send that to the finance data application. Finance application will read that file and start their processing. So data are stored as files, and data exchange are through files mostly. As a data engineer or data scientist, which I believe most of you will be, that will be your immediate job after you graduate. Um, as a data engineer or data scientist, your source data that you contact each day are likely files too, and you normally will store your immediate result as files. A few years ago, I was in a town hall discussing the career with future data scientists or current data scientists, new graduates. One of the new graduates asking an interesting question that he said, "Oh, basically what I'm recruited." I was hired as a data scientist, but instead of all the fancy machine learning and artificial intelligence works that I was dreamed of, that I thought I will be working on. Right now, I'm working with Excel every day, Excel spreadsheets every day. So, which is unfortunately very true in current data science field. Most likely, the bulk of the data you access will either be relational database or files, Excel files. So this is a typical thing happen. And just for FYI, the answer I gave him was that's inevitable, but that's a good time for you to get into business requirement and understand what the process is, understand the role of scientists and engineers in the corporate, and try to come up with ideas, suggestions to your boss on how to improve instead of sticking to files. Is there a way that you can move into a more advanced field? So this was the quick suggestion. There's a distraction from the course, but as you can see that it's very real that you will be working with data files stored somewhere, and not only traditional data analysts will be using files. In fact, recently, in these recent years, with the popularity of machine learning and artificial intelligence increase, there's a more there's a more more current trend that more and more companies are storing their result files as result data as files. Traditionally, people store the final data to database, but recently, for many different reasons, mostly because the technology advance and because the infrastructure is getting cheaper. So more and more data companies are store the final result as files. And also, there's a requirement for this because right now, as technology advance, more machine learning and artificial intelligence application can process file directly. So that's a technology advance in that people can start directly utilizing those files instead of saving those to a relational database before you can access that. So in recent years, we do see an increase in companies that are trying to store data in directly as file instead of saving that to database. Though these are the storage, right? Because data source is file comes as a file, and the data exchange are through file, and you will handle file every day, and in the future you will have to handle more files. So it's an inevitable part of data engineering and data science. Now, there are how do you store file? Of course, you will have that in your local drive, your local hard drive, right? But then if you generate a local hard drive, how do you share this with customers or your business, your users? A lot of times in the old day, and probably still the same in these days, is some data science or scientist or analyst will process on Excel spreadsheet, come up with something and save that to Excel spreadsheet and email that to everybody that is supposed to receiving the result. This is still the case these days. We only can hope that it get reduced because this one could put a lot of burden on companies' IT infrastructure and make it very hard to check change and to check mistakes. So this is not definitely not the ideal way. And improvement on that is to store the file on a file server and you make change directly on that so that everybody sees the same version. Otherwise, you send an email to yesterday, you send another email today, and send another email to tomorrow. Which one is the latest? It's very easy for someone to open up an older email, and you most likely those email are in the same email train, right? So it's very easy for someone to open up the older email in the email train and making comments and realize that he or she is working on the old version. So if you have a shared server, file shared server or disk, that you can put your data, the file in, and the people start working on that file together, that will give you much better version control and checking and the modification checking. However, the issue is those kind of file servers are usually expensive, and they have a limited volume. You have only so much space, right? So that eventually comes to what we are going to discuss today, which is cloud file storage. You will store your file in the cloud, which this is actually not a new idea, right? I believe all of you have some experience in storing your personal photos or song in the cloud. So iPhone or Google Drive, I believe all of you have some experience on that. But we are talking about enterprise level, a large volume of storage. That in Azure is called Azure Storage Account. Azure Storage Account contains all of your Azure Storage data objects. And the key here is in large volume. It can easily go to hundreds of gigabytes and terabytes and petabytes. So storage account, there's something you need to note. One is when you create a storage account, it's a place for you to store for your files. But a name must be between 3 and 24 characters in length and may only contain numbers and the lowercase letters. And more important is your storage account name must be unique within Azure. No two storage account can have the same name across Azure in all over the globe. So this is we will start creating a store coverage account in our lab, but basically this is one thing you need to note prior to we get into that. So inside storage, there are many different way of storing information. Right? We have currently there are four levels, four types of storage: blob, file, queue, and table. Let me talk about queue and table first because these two are much less utilized. Queue is basically a message queue. It's like storing some information that expecting someone will take that away. This is beyond the scope of this class, and also beyond the scope of this class is table. Table storage is you can store non-relational structured data or relational data, structured data. It's but I think recently Microsoft is trying to phase that out and ask you to switch to Cosmos DB though. So we are not going to talk about this. The two types of storage that most of you will run into in the future is a blob and a file. It's easy to understand what a file is, right? A file storage is. It's just like the same as you will have in a file storage in your company. It's a file server or some kind of file share service in the cloud that has the same your familiar folder structure that you can access, you can read and download. And there's blob. What is blob? Blob basically is the name for anything that is one chunk. So it and you can also have so when you compare blob to files, blob is one chunk of large data. It can be like a bunch of text files with data. It can be like videos, images. These are not the business file that you will usually process. So at this point, when you think about blob files, most likely you will think about like Word document, Excel spreadsheet, or the text notes, right? Something like this, or PDF files. These are files, but these are like a more like business-oriented processed files. When we talk about blob, this usually comes as a huge volumes of raw data, raw format of videos, images, pictures, and audios. This is blob. Blob generally is cheaper and simpler and most widely used. And the key here is really cheap. Blob storage is cheap because it has much less operation. So we will discuss about blob and files in this session. Okay, starting with blob. What's blob? Blob is considered as an object, not a file. So it still is a file, right? It's let's say it's a text file, for example. If you have a CSV file and you save that in the blob storage, it's CSV. And if you open it up, you can see all text inside it. But it's the difference here is how Azure will handle that. Azure will handle this as a whole. There's no operations into this file. You can have like 500 rows in a text file, 500 lines in a text file, but to Azure, it's just one file. Azure is not going to go into the file and go to row line 21 or line 34 to get the information from there. Instead, if you ask Azure to process the file, Azure either give you the whole file or don't. So this is to Azure is just one single piece of object. That's why we said it's a blob. It's not a file in the sense that it's not handled like a regular file. If you are handling a business file like a Word document, you will go to page 5 and go to paragraph 2 and make modifications. Type in three words. This then save it, right? You are opening up the file. You are modifying the file content of the file. But that's the file. That's a file storage file. But for blob, anything inside is a one piece. You just read it, and the process is up to the other team, the other side. Whoever get the file will process the file. To Azure, it's just one object. There's only one single read-write operation. There's no sequential operation, such as append or update. The advantage of blob is its low cost and tiered storage. It has a very high availability and strong consistency and disaster recovery. Basically, it all comes from the word low cost because you only handle this as a single read and write. So the process and maintenance is much easier. You just save it to disk, and you can save it to multiple disks. Usually, any file will be saved 3 copies. Then so even if one disk fail, you still have 2 other copies, and you can decide which where do you want to store these 3 copies. You can either store that all in the same data center, or you can have these 3 copies stored across 3 different data centers or 3 different availability zones. Or you can even define a cross-region duplication that you can have another copy in another region. If I save that file originally inside East US, I can define the copy to be a copy to be copied to West US. So when disaster, God forbid, if anything happens to the East Coast, right, and the whole data center or even the whole state get wiped out, I still have a copy in West Coast. So this is where you get a high availability and disaster recovery. And of course, these 3 copies is people Azure will run process, keep on monitoring to make sure they're consistent. Blobs are stored in not directly under storage account. Basically, we have a storage account, and we have 4 types of storage, right? So under storage account, you can define different structure to store those 4 different ones. Then they are not mixed together. So all blobs will be stored in a structure called container. It will be one storage account with one or multiple containers, and each container contains blob. Remember, container can contain only blob. Oh, by the way, this container is just the name for storage, for blob storage. It's not the container we discussed about when we discussed about compute. So this is the same name. Even I got confused sometimes. Literally, I made a mistake in one of the meetings when the client was showing me this container, and I was thinking he was showing me the computing container. Make a mistake and but so there's no issue in making mistake, but just remember there are multiple places where you use the word container. So when you define container, you have this account, storage account. This is the storage account URL from my account with your account name, blob core windows.net. This is the URL for your account. Then put a slash and you can place your container name after that. So you can have multiple containers under my account. My container 1, my container 2, etc. Each have its own unique URL. A container organizes a set of blobs similar to a directory in the file system. A storage account can include an unlimited number of containers, but in reality, you want to control the number of containers to keep your mind clear, right? And then there's a blob. Inside container, there are blobs. Each container have multiple blobs, many different blobs indeed. For example, this one, I have a container called test. You can see this is the storage account, and this is the container, and this is the blob name, right? So this it's not shown, but I'm just telling you here. This Junction MSFT test is the container, is the storage account name. Under this container, under this storage account, I create a container called test. And then inside this test, I created a blob called dreamshan.txt. And as you can see, each blob also has their URL, and you can see clearly there is some. This basically is part of the storage account name, just like here. It will be storage account name .blob.core.windows.net slash container name slash blob name. This is how you define the URL. It's a block URL with this size, etc. And blobs, in this case, I directly store that blob under the container, right? But you can also define folders for blobs. You can also define storage account container folder blobs. That forms the complete address of the blob. Um, how do you use the blob, right? Of course, we want to. The reason, like we said, the reason we switch from a file server to cloud file storage, why would you do that, right? Because the file storage is physically usually more distant, more further away from your office. So there is some networking spendings. Why would you do that though? The reason is cost. So cloud storage is much cheaper than usual file storage file servers, and blob is definitely the cheapest. So cost with associate that's why whenever you are thinking about moving storage to blob, the first thing you want to think is how much it costs. Storage, blob storage generally incur two types of spendings. One is a storage. Of course, you save something in the disk, right? Then Azure will charge you by the amount of bytes of volume of your storage. Um, each month. For example, per giga per month, how much will storage cost? If I have a 1 terabyte, say for 5 years, that will be 1,000 gigabyte times 5 years, 16 months times how much the cost. That's the cost. Is the storage cost. And also, when you try to access, when you try to read or write, there's also a cost associated with that. um, is charged by number of access plus the volume, then plus special retrieval fee if applicable. Not all storage account, some storage account will not charge you access fee, but some storage account will charge. I mean, some storage blob storage will not charge you a fee. Some blob storage account not only they will charge you access fee, but also some special key fee based on the feature they have. The general rule is the lower the storage cost, the higher the access cost, because in general, if you can save something in a cheaper place, this cheaper place usually is harder to get, right? There's a common sense. You don't even need a computer science degree to understand that. The cheaper storage, that means it's harder to access. So it will cost you more to access. That's why Azure have tier storage, because there are different needs. Sometimes I want to have, when I store something, I frequently will access it, right? If I'm running against some like my company's daily data, daily income, I maybe access that every day. But then there are archives. Like I have some meeting recording. Um, it's like a board meeting. I have to save it, but likely nobody is going to watch those in the next few years unless there's a government audit, which makes sense. Board meeting happens every week. Every year there are 50 board meeting videos, and 10 year it will be 500. Who's going to spend time watching those 2 hour board meeting? 500 of them, right? So usually what happens is there is some data that's hot that you will retrieve every day, and there are also some data that is cool that not necessarily you don't necessarily need to retrieve them once in a you only retrieve them once in a while. And then there are archived ones that you likely will not need to access them unless some special event happen. So hot date here, like we said, some data coming from the transactional system. I want to see yesterday's data. And this data likely will be accessed throughout the month because I want to calculate the monthly sum up, the monthly sum up, right? So this is the hot data. But once this month pass, I probably won't care about last month, what happened last month on certain date. At that time I only concerned about the monthly data. So this daily data in last month becomes cooler. I may be going back and checking the sales of a particular order, right? Maybe someone within a month, someone want to return something. That's when I still need to get back, but the frequency is much lower. Then finally, after towards within like 2 years, maybe it will be only accessed once or twice per month for a machine learning job. Right, machine learning job will go through the transaction of last 3 months, last 3 years, and identify general patterns. That's a cool tier. And eventually, after a few years, even machine learning jobs has no interest in those data, and nobody wants to access them. So we put them into archive. So you can see this different requirement for accessing can definitely shape the need of how we want to structure the spending. If for the data that's in hot status that I want to access every day, I want to minimize the excess cost, but probably with the sacrifice of some storage. I want to store it somewhere closer to me, which is and easier to retrieve, which is likely more expensive, but I can access every day, right? So that I can have a less accessing cost. And for those storage that for those files that I likely will not touch in the next 7 years, I want to save it maybe on tape or somewhere very far away. If anything happens, I have to access that, then okay, I'm willing to pay some money to get it in exchange for cheaper storage, because next 7 years I only will access it once, and more likely not. Then why wouldn't I put it in a far away place and difficult to access? And so this is what this tiered storage is about. For blob storage, you can define tiers for your blob, either on a container level or on a blob level, that you can define hot tier, which is the files access them or modify them frequently. It has the highest storage cost but lowest access cost. Then there's a cool tier, cold tier, all the way until archived tier. Archived data are rarely accessed, and that has a flexibility of latency requirements on the order of hours, which means if you want to retrieve those, you cannot retrieve immediately, but within like 15 hours. Microsoft promised you they will give you that within 15 hours, but not immediate access, because it takes them some time to go back to the data volume to read that read it out, right? Data in the archive tier should be stored for a minimum of certain times, right? Because it's archiving, but it has the lowest storage cost, but with some access cost. So this is a tiered storage. But as you can see through the discussion just now, data are not data usually don't belong to a tier forever. Usually, in the first few days it was generated, it will be in the hot tier, it will be accessed frequently. But after a while, it will cool down. Eventually, after 1 year or so, it will, depending on your particular data, it will become archive, and nobody is interested in them unless there's some auditing or something happened, right? So this is what we call a life cycle management based on time. Um, Data will have this life cycle going through different tiers at different times. For example, if I define a data should be in a hot state for the first month, after the first month, it becomes previous month's sales, right? It should go into cool tier. And then after a year, it should go to archive tier. This is the life cycle that I designed. And Azure Storage Account provides you with the ability to automatically manage or move the data through a life cycle. So you can set that on a storage account, or it can be applied to containers or to a subset of blobs using name or folders, right? It will transit the current version of a blob or previous version of blob or any blob snapshot to a cooler storage tier, or even remove it if these objects are haven't been accessed or modified for a period of time. If you haven't touched this file for a month, I assume this is a cooler one and can be moved to a second one. And it's not only moving through tiers. You can also delete it, delete the current version, and you can define the rules to be run once per day. So it is checking every day. So this is the life cycle management. Then the interesting thing is about, of course, storage account. Storage, security of the storage account, right? When you store anything online, the first thing come to my mind, to your mind, should be how safe is it? It's okay to store my picture online, right? But how about my tax return information? If I store it online, I certainly don't want everybody to see it. So the security is definitely a concern. There are multiple ways. Azure provides you with an array of different possible ways of authenticating yourself to the account, to your storage. So it started with role assignment of a user groups or managed identity. User group, that's easy to understand. When you log in into Azure portal, you log in as a user, and I can assign you access to certain storage account or certain container. I can say this user, when he or she comes to portal, he or she can see the storage account, or see but not able to access the information. They can see it. They can see the storage account. They know there is such a storage account, and they know there is such a container, but they cannot modify. They can only read. So these are all possible, but that requires a combination of your authentication, your role in your role in the Azure portal defined by administrators. They will define what you can do to each and every storage account. And there's also something called managed identity. Managed identity is basically some Azure service. So from your virtual machine, you want to access because you have a job running on your virtual machine, which will read from the storage account one, container one, and convert that into some more information and save that to storage two, container two. So the other way of accessing that is using certain tokens like access key. Access key is provided by the storage account, and you can use the access key to access the storage account container. And there's also something called the SAS security tools. All this will be discussed in the demonstration. So finally, we talked about the network access, right? When you try to access the security storage account, and as you will see later, if you use the portal, if you use the web browser to access Azure portal, and you use the Azure portal to open up a file inside storage, that file's content is actually transmitted over public internet. And this public internet access transfer, although it's properly encrypted, is also sometimes a concern. And there may be some mandates that you cannot do that. You have to use a designated network. That's where Microsoft will come up. So this traffic over internet is called public routing. That's when Microsoft come up with something called private routing, because Microsoft itself has their own backbone that is not connected to that is somehow connected to internet only at a certain point. The majority of flowing through this Microsoft backbone network is definitely separate from the internet traffic. So what you can do is you can define your storage account inside Microsoft backbone so that your network access your virtual network will access the public internet. I'm sorry, will access the secure storage account inside Microsoft backbone. So what happens is that you have your VNet, you have your virtual net, and you have this storage account. But storage account does not belong to your virtual network, right? Storage account belongs to Microsoft's own network. If you want to access your storage account from your VNet, very likely, so these are two VNets, right? Azure has its own VNet for their storage account, and you have your VNet. Usually, when you try to access the storage account, you have to go out to the public internet and get into Azure storage. So this is the popular routing. But what Azure does is it allows you to define service endpoint or private endpoint so that you will define the storage account inside your VNet. Remember, this time storage account is not defined, it's not in your VNet. You're just defining a route inside the Microsoft network to access this storage account. So thus you are able to handle the network access within Microsoft backbone and make it safer.